Alright, so this lesson is going to be about factorization. We're going to start with a rather long list of definitions. I generally don't like to have this many definitions for one lesson because I feel like it turns people's brains off. Anyway, we've got expression, equation, term, coefficient, variable, constant, operator, and then this super complicated one right here, index or indices plural, and then power or powers, or exponent and exponents plural. So let's go through each one of these one by one. So an expression is something where generally you're going to be adding, subtracting, multiplying, or dividing two things. So in this case, we've got 20a plus 8b. Now, an expression could be more than this. So we could have, 20a plus 8b minus 3c divided by 19d, and that would be an expression. So in this lesson, we're going to be working with just expressions. We're going to be factorizing expressions. But in order to kind of understand the difference here, I've also put in this definition for an equation. So the difference between an expression and an equation is, with an equation, we've got this equal sign. So basically what an equation does is it tells us that one expression is equal to another expression, or a constant. And we'll get to what a constant is shortly. But basically it's the equal sign that determines the difference. So if there's no equal sign, it's probably going to be an expression. If there is an equal sign, then it's probably going to be an equation. Alright, so within an expression or an equation, we have these things called terms. So if we use that same example of 20a plus 8b, again, and we're looking here, that expression, 20a plus 8b, has two terms in it. So the first term is 20a, and the second term is 8b. Alright, now, within those terms, each of them has a coefficient. So in the case of the term 20a, the coefficient is 20. This is just the number that we're multiplying a by. So this means we have 20 a's. The coefficient of the term 8b is 8. So that means we have 8 b's, 8 times b. Alright, this one you should know from either other classes or the previous lesson I did right before this one, which was on expansion. So this is a variable, and in this case, in the expression where we have the two terms, 20a and 8b, we have two variables. So we've got the variable a and the variable b. Alright, moving on to the next one right here. We're looking at constant. So I've changed the equation now just to have more constants in it. So in this case, we're looking at 3x plus 2 equals 8. Alright, so in this case, this equation has two constants. So the first constant is the number 2, and the second constant is the number 8. So 2 and 8 are our constants. The reason we call these constants is because they don't change. The name kind of tells you what it is. Constant means it stays the same. In the case of variables, a and b can change. They can be different numbers or values. Alright, the next one is the operator. So an operator is going to be anything that is like a plus, a minus, a multiply, multiplication, or a divide symbol, division symbol. So we've got plus, minus, multiply, and divide. If you don't know this, we use this little dot for multiply because, for example, if we continue to use what you may be used to, which is the cross for multiplication, if I have an equation like this, x times x equals 4, that's a little bit harder to read. You don't know if this is a multiplication symbol or another x, and it just looks really funny. So what we do is we use a dot because it's easy to write and it shows multiplication. So this, in this example, this would actually be x squared equals 4. So what times what equals 4? We know that this is going to be 2 because 2 squared is equal to 4. Anyway, that's just a little side note. I'm going to go ahead and erase that. All right, and on to our last definition here. So what we're looking at is, in this equation, now we've got 20x squared minus 15y squared. Now you might also hear someone say 20x raised to the second power minus 15y raised to the second power. So in the UK, we refer to these numbers above the x and the y as an index if it's just one, or indices. So in this case, for our first term, 20x squared, the index of x is 2. For our second term, 15y squared, our index is also 2. Now we could also say x to the second power, x exponent 2, or x raised to the second power. There's many different ways people will say this, but the basic idea is if you hear any of those words, it means that there's going to be a little number above your variable or your constant, and you need to raise it to that power. And I'm probably going to keep using the US way of saying these because that's what I'm used to myself. All right, so let's do some practice problems. We're actually going to start with 20a plus 8b. So the idea, actually these are all the problems we're going to do here. We're going to start with this one first. The idea with factorization is it's like we want to pull something out of the equation. So in the case of 20a plus 8b, if we're looking at this, we can't really pull a or b out because if we have 20a plus 8b and I want to take this a out, then that means I basically have to divide the whole thing by a. And what that would do is this a will cancel out, this a will cancel out, but then we'll still have this part here divided by a. And we can't just pull the a out because this is an expression and we don't have something over here to also divide by a. What we have to do is we have to then multiply the whole thing by a. So what this would look like is if we divide this expression by a, then we would end up with, we would have to multiply by a so that we're kind of putting it back the way it is. And what this would look like is we'd have a on the outside with this stuff in the middle. Now this looks very crazy, so let me write this out how we might actually do it without the arrows. So if we've got 20a plus 8b and we want to pull the a out, that means we have to divide the whole thing by a. But then, because, like I said, this is an expression, not an equation, we also have to multiply the whole thing by a. You see this a here and this a here. This is the same thing as if we did this. Watch what I'm going to do here. So we've got, this is the same thing, or it equals a over a times 20a plus 8b. But what we're doing here is we're moving this a in the bottom over here, dividing. Alright, and the reason we can do this is because what is a over a equal to? What is anything divided by itself equal to? This is 1. So this is the same thing as if we were multiplying this whole thing by 1. So let's finish this up. This is not the right way to do it. By the way, there's a better way, but let's just try it. So we divide both of these by a, and we've got our a on the outside here, so that means this is going to be equal to a. These cancel out, so that means a times, in brackets, 20 plus, and there's no a here to cancel out, so that means we have to leave this as 8b over a. Alright, now that doesn't look very nice. We kind of, in a way, we made it more complicated than it already was. So instead of doing this, we are going to look at the constants. We're going to see if there's a way to make the constants smaller. So when I say the constants, I'm talking about the 20 and the 8. Alright, so is there a common number we can find where if we divide 20 by that number and 8 by that number, it makes these constants here smaller? And you should kind of see it right away. We don't want to divide 20 by 5, because if we divide 8 by 5, that's super complicated. What's the other number we could try? Well, we could try 2. But I think we can do a little bit better than that. What if we divide both of these? What if we divide both of these by 4? Right? Then we would have 20a over 4, which would be 5a, and then we'd have 8b over 4, which would be 2b. Now, because again, this is an expression and we've divided by 4, we still need to multiply by 4 on the outside, right? This is the same thing I was saying over here, where if we do, we're just writing it in a different way, but this is the same thing as multiplying 20a plus 8b by 4 over 4. Alright, so let's write this out. So 20 over 4, that's going to give us 5a. 8 over 4, that's going to give us 2b. So then our equation is going to look like this. 4 times 5a plus 2b. Alright, and here we have factorized. You see we've kind of like pulled the number 4 out of the equation and put it on the outside here. Alright, so once we've done this, there's nothing else we can do to factorize it further, so this is going to be our final answer here, and we have factorized this. Factorized. Alright, so let's do one more. This time we've got 12s. Why does this keyboard keep coming up? This time we've got 12s minus 32t. Alright, so the coefficients, the variables, and the operator have changed. So we do the same thing as we did in the first example. So we've got 12s minus 32t. Now our variables are different, so we can't pull the variables out. So that means we should probably be looking at our coefficients, these right here. Alright, so what number can we divide both of these by in order to make these coefficients smaller? Right, so we could try 2. Right, if we did 2 on both sides, then this would be 6s and this would be 16t. Is there something better we can do though? Better than that? What about 4? So if we divide both of these by 4, then 12 over 4, sorry, 12s over 4, that's going to give us 3s. What's 32 divided by 4? Well, that's going to be 8. So then we've got 32t divided by 4 would be 8t. That looks pretty good. We can't really go any further than that. Alright, so once we've figured out our number that we want to use, what we can do is, again, we divide all of this by 4, but because this is an expression, we also need to multiply by 4 on the outside. Normally we don't write this little dot, that's just to show you what we're doing. So we're multiplying by 4 and dividing by 4. So that's really just multiplying by 1, but it's like we're pulling the 4 out of these numbers. Alright, so let's do this. So we've got 4 times 3s, right? 12s divided by 4 would be 3s, minus, and then we've got 32t divided by 4. 32 divided by 4 is going to be 8. So now we've factorized this. We've pulled the 4 out. That's one of our factors, right? So we pull out a factor. That's one way to think about it. If this stuff here is too complicated to remember, you're looking for a number that you can pull out from both sides, or a variable. We'll do some examples of that too. So we've got 4 times 3s minus 8t. We can't factorize that any further. So we're finished. We have factorized this expression. Alright, so these two examples were where we were just trying to pull out a constant from the expression. Let's go over here and do some more. Alright, so we just finished these two. Now we're going to do this one here, and this is a little bit more interesting because of the squares. Alright, so we can't pull out the x or the y because that would leave us, we'd have to have like x squared over y squared or y squared over x squared. So again, we're just going to be looking at the coefficients here, 6 and 15. So we've got 6x squared plus 15y squared. I'm going to look at the coefficients here, these two. So what's a common number that I can pull out of these two? 2 doesn't really work because 15 is not nicely divisible by 2. However, 3 looks pretty good, right? 2 times 3 is 6. 3 times 5 is 15. So let's just divide this whole thing by 3 and see what happens. And remember, because we're dividing by 3 here, that means we're multiplying by 3 on the outside. Alright, so let's try this. So we're going to have 3 times, what's 6x squared divided by 3? So we divide 6 by 3, that gives us 2x squared plus, and then we do 15y squared divided by 3. So 15 divided by 3 is 5. So that's going to give us 5y squared. And if we look at that, there's not really anything else we can do. Like, I kind of want to get rid of these, but I don't see a way to do that that would make it look kind of more nice. Like, I could do something, but it would just make it more complicated and less easy to read. So I think I'm just going to leave it there. And then we have factorized this one. Alright, so let's do the next one here, the 20x squared minus 15y squared. I'm going to do this one a little bit faster, and I'm going to say what I am thinking rather than writing it out like this with too much detail. Alright, so we're starting with 20x squared minus 15y squared. And I'm looking at these, I'm like, well, x and y are two different variables, so I'm going to ignore those for now. Then I'm looking at 20 and 15, and I'm like, well, the common number between these two is 5, right? 20 is going to be 4 times 5, 15 is 3 times 5. So I know I'm going to need a 5 on the outside. That's the common number between the two that I'm trying to kind of pull out. So we've got 5, and 20 divided by 5 is going to be 4. So we're going to have 4x squared minus, and then 15 divided by 5 is 3, 3y squared. And then I'm going to look at this again and see, is there anything I can do to kind of fix these? I don't see anything that will make me get to a nicer looking expression. So we are done with this one. Alright, this one has been factorized. Oh, that's not an E. Factorized. Alright, so now we have done 2 more. Alright, so now we're going to get into some crazier ones here. So this one here, this has 3 terms. Uh-oh. So let's do this one. It's actually not that bad. So here's our one with 3 terms. 64p minus 72q. That's not a 72, that's a 22. 72q minus 40r. Alright, so again, all of our variables are different. None of them are squared or cubed or anything, so I'm just going to kind of ignore those. And I'm going to look at these numbers and try and figure out what is a common number between all of these. And I'm looking at the smallest one here. So if we look at 40, what are some of the factors of 40? Well, we've got 1 and 40, 2 and 20, 3, no, 4, yes, 4 and 10, 5, yeah, 5 and 8, anything else? 6, No. 7, no. And then we're at 8 already. So these are some of the factors we should be thinking about to see if we can divide any of these other numbers by them to make them nice and small. So I'm going to look at these, and 1 and 40 don't help us. I'm writing this out in too much detail. Eventually you should be able to just kind of do this in your head, but we'll go through this slowly for this example. 1 and 40 don't help me because I can't divide 64 by 40 easily. Dividing by 1 just gives me 64. That's pointless. Same thing for 72. So 1 and 40 are out. 2 we could possibly do, but I think we could maybe do better than that. What about 20? No, 20 doesn't go into 64 or 72 easily. We'll have a remainder or a decimal. So no 20s. 10, definitely not. That's just that's half of 20. So we're not going to use 10. 5 is also bad because neither of these numbers are easily divisible by 5. Alright, so that leaves us with 2, 4, and 8 are what we want to consider. Alright, so let's write this out so you can see kind of how this works. So we're going to do 64 over 2, 64 over 4, and 64 over 8. And then we're also going to do 72 over 2, 72 over 4, 72 over 8, and 40 over 2, 40 over 4, and 40 over 8. And what we're going to do is we're going to see which one of these gives us the smallest numbers for all three of the 64, 72, and 40. Alright, so 64 divided by 2 is 32. 72 divided by 2 is 36. 40 divided by 4 is 20. 64 divided by 4. 64 divided by 4 is 16. 72 divided by 4, 18. 40 divided by 4 is just going to be 10. Alright, so you see how the numbers are getting smaller as we go down? This is because we're dividing by larger numbers. So what is 64 divided by 8? That is 8. Oops, wrong color. You should think of it like 8 times 8 is 64. Easy. 72 divided by 8 is 9. You need to know your multiplication tables to do that one quickly. And finally, 40 divided by 8, that's another multiplication table, so that's going to be 5. So if you look, what we've got here is these numbers are all really small. So it looks to me like we want to pull out the number 8. Alright, so what that means is, and I've kind of messed up my space here, let me move this over. That should be okay. This one we'll do later. right, so if we're deciding to pull out an 8, that means we're going to do 8 times this equation, right? We divide the whole thing by 8, which means we have to multiply by 8 on the outside. So 64 over 8 is 8. That gives us 8p. Minus 72 divided by 8 is 9q. Minus 40 divided by 8 is going to give us 5r. Alright, so we have factorized this down to 8 times, in brackets, 8p minus 9q minus 5r. And that's really as far as we go. There's nothing else that's common between 8, 9, and 5, or the variables p, q, and r. So we're just going to box our answer. And you don't have to write this when you do it. I'm just writing it to be probably too clear. We have factorized this now. All right. Finally, this is the type of expression where you'll see equations where you need to do this a lot. The 2x squared plus 4x. So here's the thing, guys. We've got our coefficients that we can simplify, and we've got our variables that we can simplify, right? Because these x's are the same. All the previous examples, we had different variables. So let's go ahead and simplify this. So I'm looking at this. I've got 2 and 4, so I'm thinking, all right, I'm going to need to pull a 2 out at least, because if I divide 2 by 2, that gives me 1. Divide 4 by 2, that gives me 2. And then I'm like, okay, these two variables are the same. I've got an x squared and an x. That means I can pull out an x also. So let's pull out an x. So now we've got 2x, and then we can rewrite this. So this one, if we pull out the 2, that means we've got 1, and then if we pull out an x, we need another x to get x squared, so this is like having 1x, right? So I'm just going to write this as x, because 1x is x. Then plus 4x, so we pulled out the 2 and the x, so 4, 4 divided by 2 is 2, and then we've got the x here, so let's say it's plus 2. Does that work? Well, let's check it. This is where you you use the stuff that we learned in the last lesson about expanding. So if we do 2x times x, that's going to give us 2x squared. And then if we do 2x times 2, that's going to give us 4x. And we would add them together, and that's 2x squared plus 4x. So we know that we have factorized this correctly, because then when we try to reverse the process and expand it, we get the same equation that we had in the beginning. That's how we know we did it right. Alright, so we are done with this one. That's factorized now. Factorized. There we go. Alright, one more, and then we're done with this lesson. This one is much longer, probably too long. Alright, so now what we've got is we've got an expression with 1, 2, 3 terms. Now, normally what we like to do in math is we like to write them in the order of the index. This here is x to the first power. So what I mean by that is normally we would like this to be in this order. We go from the highest power, or the highest index, or the greatest exponent to the lowest. So negative 18x cubed plus 15x squared plus 12x. Now the reason my operators are like this is because this one right here is negative 18x. Right, we see minus 18x, that's the same thing as adding a negative 18x, cubed. Then this one is plus 15x squared. And this one, because it's not a negative, the 12x is plus 12x. Alright, so we've rewritten that. Now we need to look for a common number between all of these. So the numbers, the coefficients we're looking at are 18, 15, and 12. And then the variable that we're looking at is x, but we've got x cubed, x squared, and x. So we need to look for a common number between these and a common variable or power between these. So let's start with the numbers first. So 18, well, I'm just looking at this. 3 times 6 is 18. 3 times 5 is 15. 3 times 4 is 12. We could also think of this as 2 times 6, but the problem is there's nothing for 15 where we can use a 2 or a 6. Alright, so we're not going to do that one. So it looks to me like our common number here is 3. Let me just move this down since... So our common number is 3, so we're going to do this is equal to 3. And we also need to look at our x variables here. So what's the common one here between all of these? Well, it's x, right? This one. So x cubed is the same as x times x squared. X squared is the same thing as x times x, and x is just x. So if you look at this, we can actually pull out an x from each one of these. And what that will do is that will decrease the powers. So since I see this x is common between all three of these, I'm going to put an x here. So I've got 3x and so this is negative 18, so we have to be careful here. So 3 times 6, but I'm going to make it a negative 6. So 3 times negative 6, and then our x squared, plus 3 times 5, and then our x, plus 5x, and then our 12 here, plus 3 times 4, and then our x here is just x, so we're going to leave this as 4. And we are done. And then if you want to double check, you can do 3x times negative 6x squared, 3x times 5x, and 3x times 4. Each one of these, 3x times negative 6x, well that's going to be 3 times negative 6 is negative 18. X times x squared is x cubed. Then we're going to add the next one, 3x times 5x. 3 times 5 is 15. X times x is x squared. And then our last one, 3x times 4. We're adding this, so 3 times 4 is 12, and we multiply by our x, that gives us 12x. So negative 18x cubed plus 15x squared plus 12x. This is the same thing as what we started with, so we checked our solution and it works. So we have successfully factorized this. Alright, and I want you to note here that I did put our variables here in each term in order going from highest power to lowest power. This is x, the negative 6x squared, so that's x to the second. 5x, that's x to the 1. This one here, we don't have an x. That's the same thing as x to the 0. Anything to the 0 power is going to be 1. Alright, and that's it for this lesson. I apologize for it being so long. I did not think it would go for 45 minutes. I will leave you with all of my notes zoomed out. Let me zoom. There we go. Let's just, can we... Alright, I don't know why this keyboard keeps coming up. But there's all the notes for the lesson. I'll leave that up as usual for a couple of seconds if you want to pause the video to make sure you've gotten everything. But that's all. Thank you.